In 1992, a highway project in San Diego exposed mastodon bones shattered in ways only fresh bone breaks, alongside battered stones and a scientific date of 130,000 years old. If true, it means humans, or something like us, were in North America over 100,000 years before our textbooks allow. Was this the earliest human presence on the continent, or something else entirely? The answer could reset the timeline of our own story. November 1992 brought a routine day on State Route 54 just east of San Diego Bay. Construction crews were widening the highway, pushing through layers of ancient sediment. Standing nearby, field paleontologist Richard Cerruti watched as a backhoe sliced into the earth. In the churned-up soil, something caught his eye, a curve of ivory, a scatter of dense, fossilized bone. Cerruti recognized the signs at once. Work halted immediately. The site, soon named in his honor, was cordoned off. What began as a standard monitoring job for the San Diego Natural History Museum turned into a 5-month excavation. Under museum supervision, the team shifted from heavy machinery to careful hand tools. They mapped and documented everything as it emerged from the sediment. Each bone, each fragment, each stone was recorded in detail. The remains lay deeply buried in fine-grained Pleistocene deposits, sediments that had settled long before modern roads or machines. Over the winter and spring, the excavation revealed the partial skeleton of a mastodon, an extinct cousin of the elephant. Alongside the bones, the team recovered 5 large cobbles, their surfaces marked and battered. From the outset, the context was unusual. The bones and stones rested together in a distinct layer not mixed with recent fill or debris. Museum field notes describe the careful salvage process, the slow reveal of an ancient scene sealed away for millennia. For the San Diego Natural History Museum, this was not just another fossil find. The Cerruti Mastodon site would soon challenge everything researchers thought they knew about the deep past of North America. The excavation uncovered the partial skeleton of a juvenile mastodon. 2 tusks, 3 molars, 16 ribs, and more than 300 bone and tooth fragments. But the condition of these remains stood out immediately. Heavy limb bones, such as femur and humerus, were snapped into large angular pieces. The breaks showed spiral patterns, the kind that form only when bone is fresh and still rich in collagen. In contrast, the more fragile ribs and vertebrae lay mostly whole, as if whatever force shattered the big bones had left the lighter elements untouched. Among the scattered remains, 5 large cobbles appeared, stones of andesite and rhyolite unrelated to the fine local sediment. Their surfaces bore the marks of hard impact, pitting, crushing, and flat facets battered smooth. Some bones displayed wedge-shaped flakes called cone flakes and swelling bulbs of percussion, hallmarks of forceful blows delivered to fresh bone. These features are well known from sites where humans have broken animal bones with stone hammers to extract marrow or shape tools. Here, the same fracture signatures appeared, yet no human remains or classic stone tools turned up in the sediment. The pattern was not random. Large limb bones were broken at points consistent with deliberate targeting. Bone flakes and fragments clustered around the cobbles, some refitting with the main limb sections. The battered stone sat close to the densest concentrations of broken bone, their wear matching the size and shape of the impacts. For the research team, these details demanded explanation. The evidence looked less like the slow work of natural decay and more like the aftermath of focused, purposeful activity, an ancient scene frozen in the earth waiting for its story to be told. In 2014, the question of just how old the Cerruti mastodon bones might be finally met the tools of modern science. James Paces, a geologist with the United States Geological Survey, received the task of dating the fossils. He turned to uranium-thorium radiometric analysis, a method that measures the decay of uranium atoms into thorium within the mineral structure of bone. This approach can reach far beyond the limits of traditional radiocarbon dating, stretching deep into the Pleistocene. Paces prepared nearly 100 small samples from the mastodon's bones and teeth, applying a model that accounts for how uranium enters and moves through bone over time. The results were consistent, clustering around a single astonishing number, 130,700 years old, with an uncertainty of just under 10,000 years in either direction. That figure stands in stark contrast to the established timeline for human human arrival in North America. According to the prevailing view, the continent's first people crossed from Siberia to Alaska between 14,000 and 20,000 years ago, long after the age recorded by the Cerruti bones. The new date places the mastodon and whatever broke its bones over 100,000 years earlier, during the last interglacial, when Neanderthals and Denisovans roamed Eurasia and modern humans had not yet left Africa in large numbers. The magnitude of the gap is difficult to overstate. If the uranium-thorium date is accurate, the Cerruti site does not simply nudge the timeline back, it rips a hole in the fabric of what archaeologists have long believed possible. The implications are profound, and the controversy would soon follow. In April 2017, the Cerruti mastodon findings appeared in the pages of Nature, signed by 11 authors and led by Tom DeMarais of the San Diego Natural History Museum. The team laid out their evidence with unusual clarity: spiral fractures on massive limb bones, cone flakes and bulbs of percussion, and battered cobbles tightly clustered among the remains. These features, they argued, match the results seen when humans use stone hammers to break open fresh bone. DeMarais and his co-authors compared the Cerruti bones to experimental work on modern elephants, where hammerstone blows produced nearly identical fracture patterns and bone flakes. The stones themselves told a parallel story. 5 large cobbles, unlike the local sediment, showed concentrated pitting and crushing as if they had been used repeatedly as hammers or anvils. A 2020 microresidue study added another layer. Bone fragments and mineral traces appeared only on the upward-facing surfaces of the cobbles, beneath ancient carbonate crust. For Daniel Fisher, a paleontologist who has spent decades studying mammoths and mastodons, these details left little doubt. In his words, he knew of no other way the Cerruti material could have been produced except by human activity. Skepticism followed quickly. Archaeologists and paleontologists across the field raised immediate objections. The absence of human bones at the Cerruti site stands out. No skull fragments, no teeth, not even the smallest trace of a hominin. Critics also point to the lack of classic stone tools. The battered cobbles, they argue, cannot be called artifacts without unmistakable signs of deliberate shaping or flaking. In their view, these stones could just as easily be natural debris, battered by geological forces, or moved by water long before the mastodon died. Heavy machinery looms large in their doubts. Heavy machinery, backhoes, excavators, bulldozers can shatter buried bone in unpredictable ways. Some researchers propose that the spiral fractures and bone flakes might have formed as the original highway work cut through ancient sediments, driving cobbles into the mastodon remains. Others suggest that over thousands of years, sediment pressure, animal trampling, or even powerful floods could have broken bones and scattered stones without any human hand involved. For critics, the evidence is intriguing but falls short. They say the Cerruti site lacks the clear layered proof needed to overturn decades of archaeological consensus. If the Cerruti mastodon site truly records the work of ancient hands, the question becomes, whose hands were they? Around 130,000 years ago, the world was home to several hominin species. Neanderthals shaped stone tools in Europe and Western Asia. Denisovans, known from a handful of Siberian fossils and genetic traces, may have ranged across much of Asia. Homo erectus, the enduring traveler, might still have survived in isolated pockets. Early Homo sapiens had only recently appeared in Africa and were just beginning to move beyond. None are known from the Americas. Yet if the evidence at Cerruti holds, one of these lineages, perhaps another, still unknown to science, somehow crossed oceans or continents to the Pacific shore. The familiar land bridge between Siberia and Alaska was not present in its later form. A coastal migration, or even a journey over open water, enters the realm of possibility. The site opens a door onto a chapter of human history that remains unwritten, its characters still in shadow. Science advances only when we question what we think we know. The Cerruti mastodon bones force us to confront the gaps in our story and remind us that ancient history can still upend today's certainties. The next breakthrough may already be waiting in the ground. What do you think?